right. We are clear for takeoff, so to speak. This is a little interesting. Shh, listen, gentlemen. The computer ate my answer key, so I'm gonna have to work these out with you. So, if you had any questions, this will be a bonus because I'm gonna work every single one of them. For those of you who didn't have questions, I apologize for the tedium. We'll see how this works. All right. For those of you who are listening at home, hi Julia. The other Julia. Well, grab your red writing utensil. Let's work these through. Number one. That is an indicator to stop the conversations, which you're still doing. Okay, that's a relevant one. Number one, S of T. What does the worksheet mean by S of T? Go, what?
Speed.
I wish. That would be nice. Michael, what is S of T on the worksheet? What's that? Say it verbally, we need a video. Yeah, it's a position function, it's x, basically. This is the same thing as x of t. Why do you use s? I really don't know. So it's t squared minus 14t. I'm not gonna write all of them in their full grossness, but, and they want t equals 2. They want the position, velocity, speed, and acceleration. So there's 4 things you have to find. First, S of t is the position. It's the exact same as x of t. So they want S of 2. So this is 2 squared minus 14 times 2 plus 45. I'm just going to kind of do mental math here. This is 4 minus 28 plus 45. So what am I doing? Question?
No.
Stay with me. Don't distract very much. 45, 25, 15, 17, 21? Is that metrics? Okay. So the position at time t equals 2 is 21. The velocity you get by taking the derivative of the position function, which in this case is 2t minus 14. You might have noticed that the velocity and the acceleration are a lot easier to plug in. So I want v of 2. This would be 2 times 2, gentlemen. I really, honestly want you to stop chatting. I think I've said that multiple times, yes. So this is 4 minus 14, which is negative 10. Can somebody, I need some units here. They didn't say how big the spaces are. So 21 spaces. The question. You didn't have to do this on the worksheet, but on the test, I'm going to be a little more picky. It's 21 spaces to the left or to the right? Which? To the right. Why did you say that? Yeah, because it's positive. It would be 21 spaces to the right of 0. Negative 10, that's the velocity. Negative 10 what? What do you think? Spaces per second. What does that mean physically? It's moving 10 spaces per second which way? To the left. That means at that very instant, its speed is 10 spaces per second to the left. Does that make sense? If I give you an actual like physics problem on the test, I'll give you units like feet or centimeters or whatever, and then you can fill those in. A of t. That's the derivative of this. You're stuck with the number 2. Gentlemen, one last warning and then I move people. You have more than enough warnings all semester. 2 what? Yeah. Spaces per second squared. Spaces per second per second. Make sense? What does that mean? A is for acceleration. What's happening to the speed? Is the speed getting bigger or getting smaller over time? John? by how much each second? It's increasing, the speed is increasing by 2 every second. Right now it's at -10, but if it keeps at this exact speed, which it won't, it'll change up and down, but pretend it did, the speed would be -10, then -8, -6, -4, -2, 0, 2, 4, and then it would start moving to the right again. You see what's going on here? So the first part of this graph, we have a particle that's basically moving to the left, but slowing down, stopping, and then moving to the right and accelerating. Is that gonna make sense? All right. Number 2, I'm gonna just kind of turbo this. I'll need somebody to read off. Yeah, question. Oh, speed. I forgot speed. Oops. Can somebody tell me how to get speed? One step will do it. Go.
Wait, I have a question.
Go ahead.
So this might be super stupid, but you can't have a negative acceleration, can you?
Question. Can you have a negative acceleration? Actually, yes, you can. What that means, acceleration basically is kind of like gravitational pull. It's, that's a good example. Now pretend this marker is traveling through air and it's going like this. It's moving to the right. No, well, sorry, moving to the left, going like this. Now pretend it's attached to a rubber band. It's moving to the right. Darn it. Moving to the left, it's moving to your left. But what's going to happen as the rubber band gets tighter and tighter? It's going to slow it down, and then what? Then whang. Exactly. That's an acceleration that way. Whichever way the rubber band is pulling is acceleration. If I had a rubber band this way, it might be going positive velocity for a little while, but there's negative acceleration fighting it. So the negative acceleration is going to fight it, and it will eventually win. So it's like, velocity is +3, +2, +1, 0, -1, -2, -3, -20. And then heaven knows where it's going to go. Does that make sense? So yeah, acceleration can be negative. That means you're pulling to the left. Acceleration can be positive. That means you're pulling to the right. In this case, they're pulling at a constant speed. If this had been like 2t, that means it'd be pulling and then pulling harder and then pulling harder and then pulling harder. How do you get speed while we're on it? What is speed compared to velocity? Yeah.
It's just like the absolute value.
Right. It's throw away any negatives. It's the absolute value of the velocity. Which in this case, what is the speed? Go ahead. 10. Yeah, it's the absolute value of -10, which is 10 spaces per second. Does that make sense? So speed is just the velocity, absolute value. Clear? All right, number 2. I'm going to go a little faster here. S of t, again, this position is -t to the 4th plus 14t cubed. And they said t is equal to 4. Michael, up here, please. So to get velocity, you take the derivative, -4t cubed plus 42t squared. Okay? If you want to plug in 4, this is -4 times 4 cubed plus 42 times 4 squared. 4, 16, 64. This is -256 plus, oh my word. 42 times 16, I don't know what it is. 16 times 12, okay, the 1's 24, 25, 42, 2, 7, 6. Okay, plus 672, 472, 422, 469. I think that's right. Does that match anybody's answer? For number 2 party for velocity. I'll double check it. It does? Okay. I'm feeling like a little cheap in order to go faster.
Yeah, that's right.
Oh, good. 416 what?
Spaces per second.
Spaces per second. Positive or negative? Michael? Positive, correct. So what does that mean, physically speaking? What's the object doing?
Going forward, positive,
Forward in, like, what direction?
to the right.
To the right, correct. It's going to the right at 416 spaces per second, which is phenomenally fast. A of t, it's the derivative of this thing. It's negative 12t squared plus 84t. And if you want to plug in a 4, the acceleration at 4 would be negative 12 times 4 squared, which is 16. 16, negative 176. No, that's stupid. Hang on a second. 160 and then 32, 192. And then plus 84 times 4, 320, 336. 236, 136, 144.
Yeah.
144 what? Spaces per second squared. Spaces per second per second. Does that make sense? Can somebody give me the speed off the top of your head? Pete?
So would that just be the absolute value of the velocity?
Correct.
So that'd just be 416.
Right.
spaces per
Still
second.
positive 416 what?
Spaces per second.
Spaces per second. Correct. Does that make sense? That's all you needed for number 1 and number 2. Let me look. Number 3. S of t is t to the 4th minus 12t cubed. Take out your graphing calculators. I want to show you something. There is, I don't want you to get reliant on this, but go to the y equals screen. Does anybody not have a calculator with them? You have a calculator? Go grab it. Go to the y equals screen. Clear out any functions you have in there already. Here, no water. With a little bit of practice, this gets pretty fast. This is number 3. I'm going to just write down the original formula. S of t is equal to t to the 4th minus 12t cubed. And they want t equals 8. Okay. On the y equals screen, I'm going to substitute on the calculator, use x in place of t. So on the first formula, I'd like you to put y1 equals x to the 4th minus 12x cubed. If you have an older calculator, it'll look exactly like that. If you have a newer calculator, it might actually do the exponent for you. I don't know. Go down to y2. Hit enter, and it'll go down to y2. Let me catch up. X to the 4th minus 12x cubed. Okay, now this one. I'd like you to type in the derivative. So do it in your head. What's the first term derivative, Polly?
4t cubed.
Right. It's 4t cubed, or in this case, it'd be on a calculator we'd use
4x.
4x cubed. Right. Same difference. And then what would the derivative of this be? Minus what?
36t squared.
Right. Or in this case, x squared. And you can use an actual squared on that. Type that into y2, and then hit enter when you're done. In y3, I'd like you to take the formula of the acceleration. So take the derivative of this. It's 4x cubed. What's the derivative of that? Julie Sushant.
12x squared.
Yeah, and then minus what?
72 points.
Correct. Type that in. catch up. So four x to the third. There is a cubed, a thing that looks neat for the, even for the old characters. It's a little involved, it goes into the math menu, and I think it's choice 4 or something like that. You don't need it, but it looks snazzy. Minus 36x squared, and then this will be 12x squared minus 72x. So this should be in y1, y2, y3. Check for typos, make sure there aren't any. Okay, as soon as you're done, hit quit, which is the second mode. Does anybody remember how to call up y1 on your calculator? How do you summon it? Like go to, should be on the home screen where it's blank, and go ahead and hit clear if there's any garbage on there. How do you call up y1?
Variables.
Variables?
Y variables.
Yeah.
Function.
Variables, y variables, so scoot over to y variables, and then function. Jack, over here, please. And what I'd like you to do, call up the y1, and then put parentheses, and I'd like you to type the number 8. Do y1, go ahead and do that. Variables, y variables, function. Call up y1, and then parentheses 8 parentheses. Hit enter. What do you get?
Negative 2048.
Negative 2048. That's the position. So S of 8 is negative 2048. Can somebody tell me what that means in the physical world? You're on a number line and there's a particle moving along the x-axis. What does that mean? Max? That would be velocity.
Sorry, I didn't kind of question.
What does this mean on the physical world, on a number line?
I forgot.
Okay, what does S of t mean? There are 3 types of function we're dealing with in problems like these. Well, 4, if you count speed. There's position, velocity, acceleration. Which one is this? I'm sorry?
Position.
Position, correct. So what does this mean?
To the left.
How many spaces?
2048.
Right. It is sitting at 2048 spaces to the left when t is equal to 8. After 8 seconds, when the experiment has been run for 8 seconds, there's where the particle is. 2048 spaces that way. So you'll have to be able to interpret this on the test. You may have to say in words, this is 2048 spaces to the left of 0. Make sense? V of 8, if you want to get a quick one, on the screen, call up y2, variables, y variables, function, and then scoot down. Or you can actually just type the number 2 and it'll select the second one for you. But then parentheses 8. So y2 parentheses 8. Somebody give me the answer there. John.
Negative 256.
Negative 256. Translate that for me. What does that mean?
Going to the left, 256 spaces per second.
Correct. It's moving to the left at a speed of 256 spaces per second. So it's pretty fast. It's not necessarily going to stay at that speed. But at t equals 8, at 8 seconds, it's going pretty fast to the left. A of 8. Michael, you're on. How do you call up, like which function in the calculator is handling our acceleration? Y1, 2, or 3? 3. Tell me how to do it. Tell me what keys to hit. Variables?
Y variables, function.
Function.
And
Y3, and then what?
parentheses 8,
Parentheses 8, what do you get?
192.
192. Translate.
Spaces per second squared.
Spaces per second squared. Right. That is sort of the strength of the rubber band. Is this thing being pulled to the left or pulled to the right? Paul. Given this acceleration, is it being pulled to the left or pulled to the right? It can be traveling at a certain speed, but there might be a certain rubber band trying to pull it to the right, or a certain rubber band trying to pull it to the left. Which one is it? Which way is it being pulled?
You say to the right,
Yeah, why do you say that?
it's positive.
Because the acceleration is positive. If the acceleration is positive, there's a force trying to make it go faster and faster to the right. Kind of like gravity. There's a source of gravity over on the right-hand side, sucking it toward, and it's going to be going faster and faster that way. Okay. If it's heading to the left, which actually it is, it will slow down, slow down, slow down, eventually stop, and then start shooting to the left, probably forever. Okay. Does this make sense? Again, few things. Number one, see if you can do this on a calculator. It will speed things up. You do have to do the derivatives in your head, which usually isn't that hard if they're polynomials. And then know how to call up y1, y2, y3. That will speed up your thing a lot. The reason, could you just do this on the home screen? Yeah, you could. But especially in cases where they give you like a bunch of different values of t, they say, okay, here's the experiment. Give me the position, velocity, acceleration at time t equals 8. Good. Now give me a t equals 10. Good. Now give me a t equals 15, which is usually what physics is going to ask. They're going to ask multiple values of t. So if you have these in the calculator already, all you have to do you remember how to call up your previous command that you typed in? There's a specific thing you can type that'll call up what you typed earlier. Second enter. Go ahead and do second enter. Y3 parentheses 8 should show up, I think, for most people. Use the arrow key and change 8 to 9. What's the acceleration at 9 seconds? 324. Good. You can immediately find a new value without typing a lot of extra stuff. Is everybody clear on that? So again, first thing, know how to use the calculator to get these values quickly. Second, be able to translate them into English. What does this mean? S of 8 means the position after 8 seconds. And then what does this mean? It's 2,048 spaces to the left of 0. This is traveling 256 spaces per second to the left. And it's accelerating, it's being pulled 192 spaces per second squared to the right. Okay. I'll eventually start asking you to make predictions. Just on here, quick review. Pete, is the particle, like at 8 seconds, because that's what we're worried about. At 8 seconds, is the particle to the left or right of 0?
To the left.
To the left. Which way is it moving?
To the left.
To the left. Which way is it being pulled? To the right. What will eventually happen? It's moving to the left and it's already to the left.
Will it slow down and be pulled back? to the
Correct.
left?
It'll slow down, slow down, slow down, and for an instant it'll what?
Stand still.
It'll stand still. I'm eventually going to ask you, when does it stand still? At what number of seconds does it stand still? As a matter of fact, I'm going to ask that now. They didn't ask this, but I will. This is algebra 0. It's also off screen. But let me see. I got to make sure I'm on this. Is everybody good at number 2? I need some space. So here's my question. When, so you're right, this thing is 2,048 spaces to the left, and it's moving to the left, so it's going further and further negative. But there's a strong pull to the right. Eventually it's going to slow down, stop. My question is, when did it stop? How many seconds? Any ideas how we can find that out? Yeah.
Could we go to the graph and like look for when it hits 0?
Definitely. Now, velocity, what is velocity on a graph? Because it's the first derivative. Max, what is the first derivative on a graph?
Velocity.
That's in physics. On a graph.
Smooth slope.
What kind of slope? Yes. One word missing. tangent slope and a secant slope. Which one is it? Tangent slope. The first derivative is a tangent slope. If you graph this, the slope will show you the velocity. So if it's going uphill, the velocity is positive. If it's going downhill, the velocity is negative. When would you know that the velocity is 0? If you just hit the what? No. A maximum or a minimum. So if you graphed it, you could look for maxes and mins. What's another way to do this? And the graph will kind of roughly show you where it is. How do you find it exactly? How do you find where the velocity is 0? You can use a little algebra on this. How do you find where the first derivative? Well, how do you find where the slope is 0? What do you do physically? Like here are your formulas. Like the s of t is equal to t to the 4th minus 12t cubed. And you can pretend that you like this. Velocity is equal to 4t cubed minus 36t squared. And then acceleration is 12t squared minus 72t. Here's the velocity. I want that equal to what? 0. Because that's, when the thing stops moving, just for an instant, that has a velocity of 0. So physically speaking, you're going to do this. Whoops, 36t squared. Set equal to 0. This basically means when it stops. You are what am I doing? When the velocity is equal to 0, that's the physics way of saying it has stopped. It's not moving. If you use algebra, you should be able to solve for t. Jack, do it. Do it. This is a 36.
You need to add 36 to.
I wish, but that's solving with algebra. When can you solve with algebra? What sort of problems are you allowed to solve with algebra? There's algebra, there's factoring, there's completing the square, etc., etc. There's only one type of problem you can solve by basic algebra. No, when you only have one species of variable. When you only have one species of t. I got 2 different species of t, so you can't add stuff to both sides, unfortunately. But what can you do?
Can we do complete this?
You could, although it's a cube.
I'm thinking
Okay. Suggestions? Go.
pull out t squared.
Factor it. Pull out, and it can also pull out a, what's the GCF? 4, and then what? This is 36. 36 t squared. So what's the GCF? Go ahead.
4t squared.
4t squared. What's left behind?
You have t minus 12, or 9.
9. Solve.
You can divide 4.
You definitely can. It won't really affect anything, but
Yeah.
zero product property
T equals 9
and t equals
and 0.
0. What this is saying is there were 2 times when your particle wasn't moving. When was that? Like you're running this experiment and say, okay, stopwatch, click. And then it starts running for like 30 seconds or something like that. There are 2 times when the particle, it's been moving all over the place, 2 times when the particle was not moving. What time values? 0 and 9. At the very beginning of the experiment and after 9 seconds. So what happens is, it was shooting to the left pretty fast, but this thing was already pulling. So something must have given it a real hard smack to the left. So it was going fast, but it was starting to go slower, 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 slower already. And after 9 seconds, it stops. And after 9 seconds, it starts slingshotting back and going faster, 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 faster. So, question. When is it going to hit the 0 point again, physically, like the position. Because right now, where was the particle at the very beginning of the experiment? Like at t equals 0. Pete?
Sorry, I was.
Okay.
I was listening.
At the very beginning of the experiment, what's the value of t when you first start? That's like 8 seconds into the experiment.
Oh, 0.
0, right. At the very beginning, pretend that t is 0. Where's the position at t is 0? 0, right. It's starting at 0, 0. Well, the center of the number line. All of a sudden, smack, something made it go to the left very, very fast. The acceleration is constant, well, not constant, but it's pulling to the right pretty fiercely. So whatever goosed it must have done it in the first few seconds. It said, okay, particle, zing. And then this thing says, oh no, you don't, come back here. And after 8 seconds, this pull is pretty strong. And after 9 seconds, it's so strong it stops it. After 10 seconds, it starts coming, after 9 seconds, it starts coming back. Does it make sense that if it starts coming back, it's eventually going to pass 0 again? When? Tell me how to find it. Yeah,
I have a question.
yeah, go ahead.
So for the 4t cubed, how did you get, t minus 9? How did
Oh,
you plug
I
that?
pulled the 4, I factored this. I pulled out a 4t squared, and then left behind 4 times 9 is 36.
Okay.
So, how do you find out when? So, do you see what's happening? At t0, here's the number line. Here's the particle, it's at 0. You know, x is equal to 0 when t is equal to 0. When t is equal to 1, it's probably going to be somewhere to the left. And it has a heyday going to the left for quite some time. But eventually it starts slowing down because the acceleration is dragging it back. So it's going over, stop. At 9 seconds it stops. After 9 seconds it starts slingshotting back. When does it hit 0 again? You're on algebra people. How do you find it? Today is pretty much a training exercise in how to interpret these things. It's great if you know how to do calculus, but cranking numbers out is only part of the battle. Then you have to tell the rest of the world who hired you as the physicist what's happening in the real world. When does it pass 0 again? Tell me how you do that. Brainstorm. What does that mean? Like physically speaking, when it hits 0, which of these 3 formulas are you dealing with? Michael. When you pass x equals 0, which of these 3 formulas would tell you that?
Acceleration.
Acceleration is how fast the speed is changing at that point.
Oh, so position.
Position, exactly. If you want to be right dead set in the middle, what do you want the position to equal? Max? 0. I want the position function to equal 0. Look up here. That is precisely what I want you to do. If I want to say when does it pass x equals 0 again, this is supposed to be x of t. You do this. T to the 4th minus 12t cubed, which is the position, set it equal to 0 and solve. Now equal to 0 is not magical. Like I could have set it equal to 3. That would tell the world when does this particle pass the position x equals 3. This is just saying when does the particle reach x equals 0. Let me do that for me. John, help me out. How do you solve?
So there's a GCF of t to the third.
Yeah, there's a GCF of t cubed. What's left behind?
T minus 12.
Okay. Solve.
0.
So what is this going to give you?
0.
T equals 0. And
T equals 12.
does this make sense? At the very beginning, it was at the 0 position. We knew that. And it also hits the 0 position one more time. On its way back after 12 seconds. At the 12-second mark, bang. It passes the 0, and it's probably never going to see 0 again. it's gonna go faster and faster and faster to the right. Questions so far? Now, we know that it was, what's the velocity at the very, very beginning of the experiment? Like at t equals 0. How would you find out the velocity at the very beginning of the experiment?
Plugging 0 to the velocity.
Yes, here's the velocity formula. Plug in 0, what would you get? 0. Did everybody see what's happening? At the very beginning of the experiment, it's at position 0, it's moving 0 spaces per second, and it has no acceleration. So it's just doing nothing. Then, at 1 second, or a half second, or something, let's just go to 1 because it's easier. Can somebody tell me the position at t equals 1? Is it to the left or to the right of 0? You want to take a guess, Jack? Where's the, after 1 second, where do you think the particle is? Left or right?
Originally?
Like it starts at 0
Yeah.
at the very
and
beginning.
in 1 second, it's going to the left.
It looks like it's going to go to the left. Prove it. How do you find the position at 1 second?
You plug 1 into the position function.
Correct. Do it. What is it?
It's F1 minus 12,
That makes what?
negative 1.
-11. After 1 second, it's -11 spaces to the left. Does that make sense? How fast is it going after 1 second? When it's at x equals -11, how fast is it going? Pete, how do you do that?
Could you just plug in,
Plug what in?
did you say 11 or something?
After at 1 second.
Plug 1.
Uh, So it was at -11 position. How fast is it going at that point? How would you find out?
Could you plug that in the position formula?
Position will tell you where it is, and we already know where it is after t is 1. It's -11 spaces over here. How fast is it going over there?
Could you plug in the velocity formula?
Yes. Plug in 1 here. What do you get? 4 minus what?
36,
What is 4 minus 36?
negative 32.
-32. What does that mean? That's velocity.
So would it just be going 32 spaces per second because it's the absolute value of
Correct.
velocity?
Speed, yes. And now for velocity, it's moving 32 spaces per second which way?
To the left,
To the left. How do you know that?
because it's negative.
It's negative. After 1 second, when t is equal to 1, we found out that x is equal to -11. The velocity is equal to -32. What's the acceleration there? Holly, help me out. How do you find the acceleration after 1 second in this experiment?
You're gonna plug in 1 to the AT formula.
The a of t. Go ahead and do it.
So that's gonna be 60
Almost.
or negative.
Yeah, it'll be +12 minus 72. So it's -60. Translate that for me. What does that mean?
So when passes, or when it's passes 1 second,
Mhm.
it accelerates -6 spaces
Yeah, so which way is it being pulled?
to the left.
It's being pulled to the left. At this instant, it's being pulled to the left. That's why it's moving to the left. Otherwise, inertia, an object at rest remains at rest unless acted upon by an outside force. Something is acting on it. Something is pulling it to the left, otherwise it would have stayed put. Now, acceleration means it wants this thing to go faster, faster, faster. Every second, it's going to try and go 60 spaces per second faster. Right now, the velocity is -32. This thing wants to go -32, -92, -152, negative whatever 60 more than that is. Okay, -212, etc. Eventually, we know it's going to start slowing down. Here's a question for you. The velocity is going this way, this way, this way, this way, this way. Refresh my memory. When does the velocity become 0? Max. when does the velocity become zero in this experiment? We found it earlier. T equals what?
0 or 9.
Yeah, either 0 or 9. We knew it was 0 at 0, but after 9 seconds, the velocity stopped. It's hovering just for an instant. Does it make sense? Watch the pen. Everybody look up here. It starts moving to the left. Does that make sense that something's pulling it to the left? There's acceleration to the left. But eventually it slows down and stops. Tell me why. Physically, what's going on? Because if there's an acceleration over here, it's going to start trying to go faster and faster to the left. Something changed. It's now slowing down and starting the other way. What must have happened? Michael.
Acceleration builds up on the other side.
Right. There was acceleration on the left. That must have stopped and given way to acceleration on the right. Does it make sense? Acceleration right now, like at 1 second, was pretty strong to the left. It was negative 60. But eventually the acceleration is going to weaken, go to 0, and then start pulling the other way. So does it make sense that somewhere between t equals 0 and t equals 9, the acceleration must have given up and switched? When? The acceleration, while the acceleration is negative, it's dragging it to the left. While the acceleration is positive, it's dragging it to the right. Somewhere in between there, the acceleration must have been 0. Find it. How? Paul, how do you find when the acceleration is 0?
Is that equal to 0?
Exactly. Take the formula and just command it to be 0. 12t squared minus 72t, and command it to be 0. This will find when the acceleration was 0. That means when it stopped being pulled to the left and started being pulled to the right. Solid for me. How do you do that?
Can you pull out a t,
Definitely, there's something else you can pull out too.
a 12.
Oh, 12. 12t, what's left behind?
T minus, sorry, I'm blanking.
Go ahead and
Six.
send it to- It's 6, yeah. Give me the two solutions.
You have t equals 0 and then t equals 6.
And t equals 6. After 6 seconds, the acceleration on the left gave up and started pulling the other way. So is the acceleration was negative, 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 negative until it hit 6. And then it's going positive, 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 and it's going to be positive forever. Because these are the only 2 times where the acceleration was over 0. Does that kind of make sense? I'm dragging you through a lot of cerebral stuff, but this is the main point of calculus. Calculus is not just a bunch of numbers thrown into the air. It's using the formulas, using the techniques for taking. We spent like a month and a half finding the different ways to take derivatives. You know, product rule, quotient rule, chain rule, derivative, trig derivatives, etc. We found, in this past month, we've spent lots of techniques on taking antiderivatives. And pretty much substitution, 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 and then integration by parts came along. Those are kind of there's basic integration, integration by parts, and then substitution integration. That's pretty much it that we know of so far. But all of these techniques are meant to tell us something about the physical world. If there's a particle moving back and forth, the fact that it's moving means it has a velocity, not 0. And if it has a formula for the velocity, you can find out, okay, where's the velocity 0? When's it positive? When's it negative? You remember plus minus notation? We're going to be bringing it back because I want to take a chart of when is the velocity positive, when is it negative. Hi, what's that?
I'm just doing the Wi-Fi assessment. Can I quickly walk through your room?
Yeah, absolutely, go for it.
Yeah.
Oh, bless your heart. If you can fix that, you'll be canonized as saint. Now, does this kind of make sense? Now, I have a little bit of a payoff for you on this. First of all, if anybody is not done with the worksheet, you're welcome to take another day for it. There is no homework for tonight. I wanted you to take a little bit of time, chew on it with your brain. I want you, understanding is more important than a half hour of homework here. I want you to know what this stuff means. Tomorrow, we're gonna be drilling on this again. I'll try and resurrect the answer key and see if I can just read off the answer a little more quickly. But, the main point, again, on the task, what I'm probably going to do is, here's the scenario, and I will say, you're gonna do quite a bit of writing, not humanities level writing. You know, you're not gonna be writing paragraphs. But I'll say, okay, what's happening at t equals 2? Or I will say, list all the significant events in the life of this particle. At the very beginning of the experiment, what's it doing and why? Explain your answer. Then, what's the very first interesting thing that happens as t starts going up to 1, 2, 3, 4? What I would say here, the very first thing that happens, the very first interesting thing that happens, is that the acceleration, from 0 to 6, the acceleration was negative, and then it stops pulling left and starts pulling right. Velocity, let's see where that was. Velocity was going to the left for the first 9 seconds, and then it stops, and then it starts going to the right. The position of this thing was going, it was left, 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 and then came back for the first 12 seconds, and then it hit here. By the way, if it was going to the left for 12 seconds, if it's to the left for 12 seconds, what would people guess as when the end point? Like if it's to the left in the first 12 seconds and then comes back, when would you guess it reached its furthest point? What's a logical guess? Like I'm over here for 12 seconds, and then like, here doggy, run that way and then come back, and then 12 seconds later the dog comes back. What did a lot of people guess was, what time did they reach the furthest point?
6.
6, perfectly logical. Is that true? Did it reach the furthest point over at 6 seconds? I'll give you a hint. At the furthest point over, the velocity stopped. When did the velocity stop? Not at 6. The acceleration stopped at 6, which is interesting. Stopped at 9. So it spent a lot of time moving left. And then it took 3 seconds to catch back up what it dilly-dallied going up. It's sort of like dogs sort of meander. Holy mackerel, I gotta get back. Zing. So the first 9 seconds, it was going to the left. And only the last 3 seconds, it moved back. But it turboed over. It just booked over and caught up all of its extra space. Does that kind of make sense? Just visually? All right, so let your brains cool off. Julia, if you're still with us, God bless you. We'll see what happens. Please stand. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Alrighty.
Bye, Julia.
Hi, thank you.